I have to start off with a joke, and this is how it goes. What do a person holding a bee in his hand and someone's eye have in common? What is someone holding a bee in his hand and someone's eye have in common? Yes.
Beauty is in the oh shoot! Bee holder, not.
Beauty is in the eye of the bee holder. Okay. Thank you.
Wait, were they beautiful?
I don't know. Okay. So, I'm not sure if that's how it goes. That's just random mind thoughts. So anyway, we're going to show that n. So this is mathematical induction. This one's a little bit different, but we're going to try to do it. So n squared, show that n squared plus n is divisible by 2. So the first thing, let n equals 1, and you're supposed to show that it's true for n equals 1. That's always the first step. So 1 squared plus 1 equals 2, right? And since 2 is divisible by 2, that checks out. Yes? Do you get that?
Yes.
So far? Okay. Now, assume true for,
Why don't you just use n instead of k?
assume true for n equals k, because we're plugging in different things for n, right? In the second part, we plug in k plus 1. So you can't just, it'd be kind of confusing if you're plugging in n for n. So assume true for n equals k. And so you get, so assume k squared plus k is divisible by 2. Let's just say that's true. It's divisible by 2. And then 3, you're supposed to show true for
that k squared plus k is divisible
n equals k plus 1. Can you just let me finish? Okay? So what you have is k plus 1 squared. Because what I'm doing is I'm plugging in k plus 1 in here, right? Plus k plus 1. Right? And then I simplify this and I get k squared, or multiply it out, plus 2k plus 1 plus k plus 1. And all together, I have 2k plus k. What I'm going to do is I'm going to group this together, k squared and k. Right? So now I'm going to rewrite this as k squared plus k plus, how many k's do I have left over? 2 k's and plus 2, right? So I have 2k plus 2. So what can you tell me about this part of it? It's divisible by 2, right? Divisible by 2, because I could factor out a 2. And I assumed that this was also divisible by 2 up here, right? By 2. See, k squared plus k is divisible by 2. So this is divisible by 2, and this is also divisible by 2. That must mean the whole thing is divisible by 2, because if it's divisible by 2, then I could factor out a 2 out of the entire expression. You understand that? Okay? So that's kind of the way that one works. Okay? Yes? Sort of? That's not that bad. Okay? You should definitely be able to do one of the previous ones that we went over, 1 and 3 and stuff like that. And we can look at number 23, but I think 23 is really kind of pretty easy if you think about it. Okay? It says, show that if x is greater than 1, man, I don't like red. Do you like red?
I like rainbow.
How about this color? If x is, so let n equal 1. So if x is bigger than 1, what can you tell me about step 1? X to the 1, does that have to be greater than 1? Right? If this number is greater than 1, does this expression have to be greater than 1? Is anything raised to the,
X has to be, no, n has to be greater than 0.
what? It doesn't say that, right?
We'll know what it has to
And
be.
x, oh, sorry. If x is bigger than 1, then x to the n is bigger than 1. So is x to the 1 bigger than 1?
No.
If this number is bigger than 1,
Yeah.
say like 1.1 or 1.5 or something like
Can it
So if I-
be non-integer?
that. Yeah, it could be non-integers, but as long as it's bigger than 1, right? This expression is bigger than 1. Okay? Just, then 2, let's, or assume x to the k is bigger than 1. So we're just going to assume that's true. And then in 3, we show true for x, or sorry, n equals k plus 1. N equals k plus 1. Assume true for n equals k. So now I'm going to show n equals k plus 1. So I'm going to show that x to the k plus 1 has to be greater than 1. So I could rewrite this as x to the k, right?
We use log.
Times, no, you don't have to use logs, times x to the 1. Yes? Okay? Well, if we already assume that this number is bigger than 1, and if this number, right, up here we assumed x to the k is bigger than 1, and if this number, if x is bigger than 1, what do I know about x to the 1? So anything bigger than 1 in here is going to make this number bigger than 1, okay? So this is bigger than 1. And if x is greater than 1, which it says it is up here, then this expression also has to be bigger than 1. And if I multiply any two numbers that are bigger than 1, what am I going to get? Is that number going to be bigger than 1?
Yes.
Yes, right? So if I like 1.1 times 1.1 or 1.2 or any number, if I have two numbers that are both bigger than 1, I multiply them together, then I've kind of shown that that expression has to be bigger. Okay, so you could kind of write that in words or something. That's kind of a weird one, but it works. Okay, that's all for going over the homework. That's called mathematical induction. And you guys at Disney World, you say hi to Mickey for me. Okay, bye boys and girls.